Hello everyone, this is assignment 15, question 17. In this case here, you have some neon gas, and I've pulled all of the important variables out of the question. So we have 0.5 moles. You're told you start at a pressure of 1 atmosphere and a temperature of 273, pushing against external pressure of 0.1 atmosphere until you get to 0.2 atmospheres on the inside and a final temperature. And you want to find work, delta U, and heat. So start out with work. Our equation for work is minus P external delta V. We don't have V in this case, but we do have moles and pressure and temperature values for each of the two states, initial and final. You know that volume then will equal nRT over P for each of those cases. Now you can either go ahead and solve for V1 and V2, and then plug that back in up there, or you can write everything out together, knowing that you have commonalities. N and R are staying the same in both cases. So you can have NR times T2 over P2 minus, oops, sorry, ignore that, minus T1 over P1. So either way you solve it, to get in the end, just watch out for your units in this case. So you're given all your pressures in atmospheres. You're given your temperature in Kelvin, which is fine. So if you have pressure in atmospheres, your R is going to be little r, right? 0.08206 liter atmospheres per mole Kelvin. And of course, you could have switched this into pascals. If you go to pascals, I'm going to do all of them in pascals, then you would use your big R. 8.314. In this case here, I'm going to keep it in liter atmospheres, which is perfectly fine. But just watch what happens on your final answer here. So you're going to get minus 3.19 if you cancel everything out. This is liter atmospheres, your units. This is not joules. This is one of the big problems that we end up seeing in the questions, is watching your units. So you have to change this into joules because we don't report work in terms of a liter atmosphere unit. And the easiest way to do this is to use that conversion, atmosphere to pascals, or also to kilopascals, sorry, not to pascals, atmosphere to kilopascals, or you can use your two R values because you have a liter atmosphere R value and you have a joule R value. Either way you want to do it, 0.125. This is the common conversion factor. Okay, oh, sorry, joules per liter atmosphere. There we go. So you end up turning your work into minus 323 joules. And like I said, if you don't remember this one necessarily, you're generally given your two R values. So you can always do 8.314, that's joules per mole Kelvin, over 0.08206 liter atmospheres per mole Kelvin. So those moles Kelvin just cancel each other out, and then you're ending up with your joules. Okay? Now the next part wants you to get delta U. So just erase here for now. So remember, for an ideal gas, you can always calculate delta U from NCV delta T. It doesn't have to be a constant volume process. You need to know what CV is. In this case here, you're told that it's neon gas. Neon is monatomic, so that means that CV is going to be 3 halves R. Remember, that had to do with the degrees of freedom for the different styles of gas. So that means, in this case here, you're going to have 3 halves NR delta T. We have N, we have R, we have delta T. In this case here, you go ahead and you use 8.314 joules per mole Kelvin, because you want to have an answer in joules, and all we're canceling out are kelvins and moles. So you should get, out of this equation here, minus 393 joules. And the last part is to find Q. So you know your equation, delta U equals Q plus W. So delta U minus W. So you are going to end up with minus 70 in this case here? Joules. Yes, as your final answer. Make sure I had the right answer there. And that's everything for this question.